Okay, moving along. We're almost ready to get back to the activity. So factors of numbers are what I want to take a look at next. So physically, we played around with finding factors of a number by taking a number of blocks, like 12, and seeing how many different rectangles we could make out of them. And we played around with that last class. So I just want to look at a non-physical way of that same idea. So when we make the rectangles, we make a base times a height, or a width times a height, whatever you want to call it. But we're taking a number like 12 and we're saying, okay, 12 is a group that's 1 by 12. So what I want to do is I want to write pairs of factors for the number. So one way to do it is 1 times 12. What's the next obvious way to make 12 multiplying a pair of numbers, a pair of factors? Two and 6, yeah. So next I would say, okay, 2 times 6 would be next. And then what?
3 and 4.
3 times 4. And then I might be thinking 4 times 3, but I've already talked about both of those, so now I'm repeating myself. So once we start to repeat, we're done. And sometimes that repeat happens pretty quick, but sometimes it takes a bit for that to happen. So if I can generate a systematic set of pairs of factors, then that means I know all the factors now. The factors of 12 are 1, 2, 3, 4, 6, and 12. So I'm just going to demonstrate that technique again using factor pairs, which is really the same thing we were doing with those physical blocks, trying to make a given number into a rectangle. So let's try 36 as a fun one. So we want to find factor pairs, which will give us a list eventually of all the factors. So always start at the beginning, 1 times 36. And then if 2 works, do it. So 2 goes into 36. Yeah, I think 18 times. And then let's see, does 3 go into 36? And calculator might be nice sometimes. You think 12 times on a good day? 4. Does 4 go into 36? And I'm hoping for some audience participation, so it's not just me here. Oh, thank you, Evan, you rock. 4 times 9, let's see, 5. No, it doesn't end in a 5. 6. Thanks, Monsi. 6 times 6, right? Yeah, thank you very much. And then, hey, there's my repeat, done. And when I list the factors, I don't need to state it twice. So if I needed to list all the factors of 36, I can do that without double stating that. So list factors of 36. So this was my process to make it happen. Now I can say, all right, that's 1, 2, 3, 4, 6, 9, 12, 18, and 36. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 different factors.
Hey, Gary, I'm sorry, I have to step out for about 10 minutes. I just want to let you know I'll be right back.
Okie doke, I'm recording. All right, so again, factor pairs, let's try it on another number. How about, oops, wrong way. Did we do 51 in the last class? I can't remember. That sounds familiar. Let's do it now anyway. So 51, I want to find the factors of 51. So 1 times 51. 2 doesn't work. 5 plus 1 is 6, so 3 goes in there. And let's see, 3 goes into 5 once with 2 left over. That's 21. 3 goes into 21 7 times. So 17 is the next one. And 17's ringing a bell. What's special about 17? Anyone? Think of anything special about 17? Evan says it's prime. It is. Now, interestingly, since 3 is prime and 17 is prime, there aren't going to be any other factors. So I could make a note that I'm done here. Since 3 and 17 are prime, there aren't going to be other factors. If you're not convinced of that, your only recourse is to keep searching. Now, 2 did not work, right? So that means no even number will work. So I really don't need to check any more even numbers. So I don't have to bother with 4. 5, it's pretty obvious. 5 doesn't work because it doesn't end in a 5 or 0. 6 is even. 7, I would have to check, and 7 goes in 49. And yeah, we definitely did this number last time, but that's okay. It's still fun. 8's even, who cares? 9, let's see. 9 goes into what? 45, and then 54, but not 51, so 9 is out. 11 goes into 44 and 55, but not 51. 12 is even. 13 we'd have to check. Let's see, 13, 26, 39. What's next? 39. 52, yeah, 13 doesn't work. Close though, no 14. 15 I don't have to check because 5 didn't work, 16's even. Then I get to 17 and that's a repeat, so I am done. So interesting, what numbers did I have to check along the way? I had to check 5, 2, 5, 7. I did check 9, 11, and 13. Mostly I only check prime numbers, which is kind of interesting. Is that special or not? So anyway, 51 has 4 factors. And finding factors is a lot of work because it means you have to do some division. And the factors are 1, 3, 17, and 51. All right, so factor pairs allows us to list all of the factors. Sometimes we find prime factors in there, but a lot of the factors are not prime here. All right, so next.